Second up today, we've got this question. And here we go. So here we have a tennis ball that is rolling up the slope, and then obviously it's going to roll back down again. And that means that it is travelling along a line. It doesn't matter that that line is diagonal, it's still motion in 1D. And in fact, it's going to be 1D suvat, this question, because the acceleration along this line is constant. How can we tell that? Well, if we look at the graph, that's the quickest way, because here we've got velocity against time, and so the constant gradient means constant acceleration. But where is it coming from? Well, if we remember when we had an object that was in equilibrium on a slope, here we had the normal contact force cancelled out by this component of the weight, and then the friction was being cancelled out by this component of the weight. And so overall, there was no resultant force on this object. However, in our question, we're told that the ramp is smooth, which is them essentially saying friction is negligible. And so if we take this friction force away, we can see that the component of the weight here, which is down the slope, this is not being cancelled out. So this is where the acceleration comes from. This is why it's constant. It's because the force, resultant force on the object, is the component of the weight down the slope. Okay, but what we're being asked to do is to describe, we don't have to do any calculations, but we've got to describe the motion of the ball over the 3 seconds. And just need to point out that this is where it's being rolled up the slope. So that means that this is it moving up the slope, and then negative must be back down the slope. So positive is moving up the slope, negative is moving back down the slope. Okay, and so what we're going to say is the ball is launched up the slope at 4.0 meters per second, and it then slows down. Its acceleration is constant. For good measure, we're going to say that's the component due to the component of the weight down the slope. So constant acceleration as it slows down. And then at 1.5 seconds, its velocity is 0. This is where it reaches the highest point up the ramp that it gets to. And then it's going to accelerate back down the ramp. The acceleration is still constant. And then at 3 seconds, it will have arrived back where it started from, and its speed will be 4 meters per second again, but this will now be down the ramp. That's more than enough detail for the 3 marks. And then the last part of the question asks us to calculate the maximum distance d travelled by the ball. Well, we've said that this is where it gets to the top. When it slows down, v is momentarily 0, and then it speeds up back down the slope. So that's where it reaches the top. And remember that the displacement travelled is the area between the axis and the line. So this area in here, this triangle in here, that is the displacement as it moves up. If you calculate that, you're going to get this. I've drawn it here just so we don't have to keep moving the paper around. Now notice, so now you've got your 2 marks, but notice before we leave this question that this is plus 3 meters as it moves up, and then this would be minus 3 meters as it moves back down again. And so adding these 2 together, we get a total displacement of 0 by the time the ball has moved up the ramp and come back down again.